welcome to Unit 1, where we're going to review linear and nonlinear functions. One of the first things we're going to discuss is slopes and equations of lines. You should recall the Cartesian coordinate system shown in the figure to the right, which we all know that we use for graphing points and lines and curves and things like that. In order to graph, we need to have ordered pairs, which we have our x-coordinate, which comes first, and then our y-coordinate, which comes second, and it corresponds to the different axes on the Cartesian coordinate plane. So you've got your x-axis, which is your horizontal axis, and your y-axis, which is your vertical axis. Both of these axes intersect at a point here, right in the center, called the origin, and that point has ordered pairs of 0, 0. And the axes also divide the coordinate plane into 4 quadrants. You've got quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And we read these starting in the top right, and we go counterclockwise. We have specific ordered pairs, which are called the x and y intercept. So this is just the x and y values of a point where the graph of an equation crosses the x-axis and the y-axis, respectively. So an example of an x-intercept could be the point 1, 0, as you see labeled here on the graph, because that is where if we were to draw some type of curve or line that goes through that point 1, 0, that is where the graph crosses the x-axis. And then, of course, you can see another x-intercept, which would be -5, 0. And then we have 2 y-intercepts labeled here, which is where the graph will cross the y-axis. One of them is at 0, -4, and the other is at 0, 3. Notice for the x-intercept, the x-coordinate has a value, but the y-coordinate is 0. And for the y-intercept, the y-coordinate has a value, but the x-coordinate is 0. So one of the things we're going to look at is slope, which is just the steepness of a line, but it's a lot more than that. We're going to look at non-vertical lines, but also vertical lines. So eventually we're going to have points which will connect, and we'll be looking at the steepness of the lines created by those points. The slope is symbolized using the letter M, and slope, if you'll recall, is just the vertical change, which is also known as the rise, divided by the horizontal change, which is also known as the run. When we look at change, we use the Greek symbol delta, which is a little triangle. So you may see this formula change in y over change in x, or delta y over delta x. And the way we find the change is by subtracting the 2 coordinates. So we take the 2 y values, y2 minus y1, and subtract those and divide it by the difference of the 2 x values. So for instance, if we were to find the slope of the line that passes through, let's say, this point and this point, one of those coordinates would be labeled x1 and y1, and then the other coordinate would be labeled x2 and y2. And you simply plug in the values into the formula. So in the top we have our y2 minus our y1, so those would go there, and then we would subtract those, and then in the denominator we would have our x2 minus our x1. So let's practice finding the slope or the steepness of the line that passes through the points 7, 6, and negative 4, 5. So if you were to visualize those 2 points on the coordinate plane, we want to find the steepness of the line that passes through those 2 points. So one of them I'm going to label as x1, y1, and it doesn't matter which ordered pair you designate. You just need to keep the subscript the same. So the 1s need to stay together and the 2s need to stay together. So that coordinate is going to be my x2, y2. So to find the slope, it's change in y over change in x. So to find the change in y, I'm going to subtract y2 minus y1, and then I'm going to divide that by x2 minus x1. And here you get negative 1 over negative 11, which of course we would not leave like that. We would simplify to 1/11. So what that tells me is that if we were to graph those points, in order to go from 7, 6 to negative 4, 5, we could go up 1 and right 11, or you could even go down 1 and left 11. What I'd like you to do is pause the video and practice finding the slope of the line that passes through each of those points. And then you can unpause when you're ready to move on. Let's talk about equations of lines next. We're going to look at different types of equations, but let's look at linear equations. And of course you can see the word line in the word linear. So we're specifically looking at equations of lines. It's an equation in 2 first-degree variables that has a line as its graph. One of the forms we're going to look at that's a very useful form is called slope-intercept. And we use the slope and then the y-intercept. So the slope-intercept form of an equation of a line is y equals mx plus b. And we know that m, from our previous discussion, stands for slope. B is going to be the y-intercept. Remember, that's where your x is 0. And then x and y are just any coordinates or points on that line. So let's find the equation of a line that passes through the point 0, negative 3, and it has a slope of 3/4. Okay, so here, automatically, I can see that if I want to write this in slope-intercept form, the 2 things I need are the slope and the y-intercept, and I actually have both. So I know my slope is 3/4, and I also know that my y-intercept is 0, negative 3. So that tells me that b is negative 3, because that's my y-intercept. And now all I need to do is just plug that into my equation. So that would be y equals mx, and then plus b here are positive turns negative because it's plus a negative 3. So that would be y equals 3/4 x minus 3. Now I need to find an equation in slope-intercept form for a line that passes through an x-intercept of 7 and a y-intercept of 2. So again, I need m and b. B is easy, it's 2. Okay, what I'm missing is m. So I need to find m. So remember, the way you find it is just the change in y over the change in x. So here, I know that another way of writing my x-intercept would be 7, 0, and my y-intercept is 0, 2. So if I designate one of them as my x1, y1, and my other is my x2, y2, I could just simply plug in here 2 minus 0 over 0 minus 7. And here you get negative 2/7. So now my equation is just y equals negative 2/7 x plus 2. Now what if I'm giving the equation of a line, it's not in standard form, or it's not in slope-intercept form, right? Because it's not y equals mx plus b. We call this standard form. So if I need to find the slope, I need to write this in slope-intercept form. So I just need to manipulate it and move some things around. Okay, so what I need to do is solve for y. So I'm going to take my equation and I'm going to isolate y. So the first thing I'm going to do is subtract 3x. And you get negative 4y equals negative 3x plus 12. And then the y is still not isolated, so I'm going to divide everything by negative 4. And you end up with y equals 3/4 x minus 3. So it asked me for the slope, and I know that the slope is m. So since it's in the form slope-intercept, I can easily pick out m, which is 3/4. Another form of a line is called the point slope form, which is pretty useful when you're given any point and then a slope. So it's much easier to use this formula when you're given any point and a slope compared to the slope-intercept form, which is useful when they give you the slope and the y-intercept, or you can easily find those. So the point slope formula is y minus y1 equals m times x minus x1. And again, we know that m is just the slope. And x1 and y1 are your point on that line. And then of course, x and y are any other point on that line. So let's say I want to find the equation of a line that passes through the point 3, -7, and it's got a slope of 5/4. So this time I have my m, but I don't have my b. So I'm going to use the point slope formula. Now, you can also use the slope-intercept formula and work backwards and find b. And if you're comfortable doing it that way, you can. That is completely fine. But I find the point slope formula to be pretty useful. So I'm going to plug in now my points. I've got y minus my y1, and here my y1 is -7. And my slope is 5/4, so I know that's m. And then it's times x minus x1, and x1 is 3. So now I'm going to go through and clean this up a little, and you would get y plus 7 equals 5/4 x minus 15/4. Okay, now I want to put this in slope-intercept form. So to do that, I need to put it into y equals mx plus b form. So I need to subtract the 7. And now you would get y equals 5/4 x minus 43/4. Now, if you're wondering where that 43/4 came from, here's a very quick lesson on fractions and subtracting. So I'm going to put a 1 under that -7, and I need to get a common denominator. So if I look at my denominators 1 and 4, I know that 1 and 4 can both divide into 4. So 4 is my common denominator. So the -15 just stays the way it is, right? But I need to create an equivalent fraction for -7. Like, how would I write that in terms of fourths? So all I need to do is just figure out, okay, 1 times 4 gives me 4. So then I need to multiply -7 by 4, which would give me -28. -28/4 is the same thing as -7, right? So all we did was create an equivalent fraction. And now since my denominators are both 4, I can add the numerators, right? Or subtract them, whatever the case is. So here I'm going to add -15 plus -28, which gives me -43, and it's over 4. At this point, I'd like you to pause the video and practice some of these problems on your own, and then you can unpause the video when you're ready to move on. The next thing we're going to look at is parallel and perpendicular lines. So if you'll recall from geometry, parallel lines are two lines and it could be more than two lines, but they're lines in the same plane that never intersect. Okay, and here we're going to focus on two lines. But what else is important about them is that their slopes are going to be the same. So parallel lines, we need to remember, have the same slopes. And for perpendicular lines, right, you might recall that perpendicular lines are lines that intersect at a right angle. So that's what makes them special. And their slopes, if you were to multiply the slopes of perpendicular lines, their product would be -1. So the product of the slopes equals -1, or you could look at it as they are negative reciprocal slopes. So what I mean by that is maybe one slope is 2/3, and then the slope that's parallel to it, we'll call it M2, slope 2, would have to be a negative reciprocal or opposite reciprocal. So you change the sign. So since 2/3 was positive, now it's negative. And then the reciprocal is just the fraction flipped over. And if you multiply 2/3 times -3/2, you get -1, right? So their products have to equal -1. And then something else to remember is that the lines, one of them would have to be vertical and the other would have to be horizontal, of course. If one of them was vertical, the other would be horizontal. They don't have to both be one vertical, one horizontal. They could look diagonal. All right, so let's find an equation of a line, what we've been doing. This time it passes through 3, 5, and but it also has to be parallel to the line 2x plus 5y equals 4. And we want to write our answer in slope-intercept form. So again, anytime you write an equation of a line, what two things do you need? You need a slope and any point, okay? It's great if you have the y-intercept, but in this case, we do not. We have the 0.35. All right, so that means I have a point and a slope, so I'm going to use the point-slope formula. Now, where's my slope at? It's found within this equation. So to find the slope, if you'll recall, we want to solve for y and put it in slope-intercept form. So we're going to subtract that. And then I'm going to divide by 5. And I end up with y equals -2/5 x plus 4/5. So my slope is -2/5. Well, since the line that I'm finding the equation for has to be parallel to 2x plus 5y equals 4, I know that parallel lines have the same slopes. So that tells me that for my new equation, the slope is going to be -2/5, just like the 2x plus 5y equals 4, okay? And I also know this line has to pass through the 0.35. So I also have this information. So I have a point and a slope, so I'm going to plug it into the point-slope formula. Again, you can plug it into y equals mx plus b and work backwards and solve for b and then plug everything in. If you're comfortable doing it that way, that's fine, but I'm going to do it like this. So you get y minus 5 equals your m times your x minus x1. And then, of course, I'm going to distribute the -2/5. And then I'm going to add 5 to both sides. So you get y equals -2/5 x, and then I need to add 6/5 plus 5. Well, that's actually just 5 and 6/5. So I can change that mixed number to an improper fraction. 5 times 5 is 25, plus 6 is 31. So that's just 31/5. And there you go. So if you were to graph 2x plus 5y equals 4, and then graph this line here, you would see that they are parallel. So I can show you, if you go to Desmos, right, which is a great free app that you can use. Here's my original equation, 2x plus 5y equals 4. And remember, I'm going to create a new equation that passes through the point 3,5 and is parallel to that red line there. So here, my new equation was -2/5 x, and then it was plus 31/5. So as you can see here, the blue line is parallel to the red line, and it also should pass through that point 3, 5, and as you can see, it does. Okay. Let's look at a perpendicular example. So here we want to find the equation of the line L passing through the point 3, 7 and perpendicular to the line, having the equation 5x minus y equals 4. So same thing, we have this equation, we want to create another equation of a line that passes through this line, but it also has to pass through 3, 7 and be perpendicular to this, okay? So again, I'm writing the equation of a line, I need a point and a slope. I don't have the slope, but I can easily find it, and I do have a point. So let's find the slope first. So 5x minus y equals 4. We of course know that we need to solve for y, so I'm just going to add the y to the other side and subtract the 4, and I get y equals 5x minus 4. Okay, that's in slope-intercept form. Y equals mx plus b. So here m is 5, but if you remember, the line has to be perpendicular, right? So when it's perpendicular, I need to find the opposite reciprocal of that number. So what is the opposite reciprocal of 5? Well, I can find it like this. 5 times some number equals -1, right? Their product has to be -1. So I'm going to divide by 5 on both sides. So m equals -1/5. So my new slope is -1/5, right? Because 5 times -1/5 is -1, and that tells me that if the product of the slopes is -1, they're perpendicular. Okay, so now I have a slope and I also have a point. So I'm going to, surprise, plug it into the slope-intercept, or the point-slope form. So I've got y minus y1 equals m times x minus x1. And then of course, we're going to put it in slope-intercept form. So I'm going to distribute the -1/5. And then I'm going to add 7 to both sides. And when I add 7 to 3/5, remember it's just 7 3/5, which again, I'm going to change to an improper fraction. 5 times 7 is 35, plus 3 is 38. So it's 38/5 would be my y-intercept. So there's your equation. So again, this time you'll see when I go to plug in my original equation, it was 5x minus y equals 4. And my next equation, the equation I found was y equals -1/5. And then it was x plus 38/5. And as you can see, they are perpendicular. They're forming 4 right angles. And it also had to pass through that point. So the black line needed to pass through the point 3, 7, which you can see it did. At this point, you can pause the video and you can try reading these application problems. And when you are ready to unpause the video, you can follow along here. And we're going to look at other forms of a line. So another form of a line, we call it the alternate form, or I mentioned earlier, it's the standard form of a line, is just ax plus by equals c. Okay, and an easy way to find the x-intercept is just take c divided by a, because remember your y will be 0, so essentially this just goes away. And your y-intercept, you probably guessed it, is c over b. Because when you're finding a y-intercept, x is going to equal 0, so that's going to go away. Some things about alternate form, the a and the b need to be whole numbers, so no fractions, and a typically should not be negative. Okay, so those are little caveats when you're writing an equation in standard form. You also have another form called the intercept-intercept form, and it's a variation on the alternate form, and basically it's just x over a plus y over b equals 1. And the a value is your x-intercept, and the b value is your y-intercept. Okay, let's look at some graphs of lines. So when you're given an equation and you need to quickly graph it, you can, of course, place it in slope-intercept form, which is what this is in. If it's in alternate form, you can find the intercepts and then plot the 2 points and draw a line through it. There's a lot of ways to do this. Since this is already in slope-intercept form, I'm going to use what they give me, which is my slope, and that's -3/2, and then the y-intercept, which is 6. So I'm going to begin at b, at my y-intercept. I'm going to go up to the number 6 on the y-axis, and I'm going to put a dot. And then I'm going to use the slope. Remember, slope is rise over run, and it's steepness. So from this point, I'm going to rise 3, even though that negative's there, just disregard it for a second. You're going to go up 3, 1, 2, 3, and then I'm going to run in the direction of the sign. So since it's negative, negative's left, I'm going to run left 2. Okay? Now, if you don't like doing that, you can always, of course, go down 3 and then go right 2. And as you can see, you're still lined up with the other 2 points. But I always think it's easier to always rise and then run. Even if it's a negative, you're still going to go up. You're just going to run to the left. If it's a positive, you're going to run to the right. But you always rise. Okay, and then you've got your 2 points, and you're going to draw a line through it. And lines, remember, extend forever in all opposite directions. So you want to put those arrows on there. And then as you notice here, graphing y equals -3, it's missing the x, right? And it's because there is none. And that's because the slope is 0, right? So another way of writing this would be y equals 0x minus 3. So what that tells me is that the y-intercept is -3, okay? And if the slope is 0, if you tried one of the check your understanding problems from earlier, you'll recall that any line with a slope of 0 is horizontal because there is no rise. There's only a run, right? So it's 0 over something. So there you just have y equals -3, which of course all along this line, y is equaling -3. Like that's 1 -3, 2 -3, 3 -3, and so on. And that takes us to the end of 1.1. In the next lesson, we're going to look at linear functions and applications. Have a great day, everyone.